Okay, in this video we're going to go through density, but first you got to make sure you go to Schoology and watch this mass song and this weight video and write down the notes of what is the difference between mass versus weight. When you've done these two things, then come back here and continue this video to watch the density notes and write them in your science notebook. When you're done with all this today, you can do the metric measurement lab or finish that one we started the other day. So, what is density? That's where we start here. So, is this density? Well, maybe not. What about something like this? The sign has sharp edges. Do not touch the edges of this sign. Kind of built for some people that we say maybe are dense. But in truth, density is, in science, it doesn't have to do with intelligence at all. It's technically, not technically, it is a physical property of matter. So this is what you need to put in your notes. So it's a physical property. I mean, again, what is a physical property? It's a property of matter that can be observed or measured. We're going to be doing a lot with density over the next couple of weeks. And as a physical property, we say it's a property that doesn't change. Now, I have this unless because there can be changes in densities, which we'll learn about in a bit. But for now, let's think of physical properties or things that don't change, and density is an example of that. Another way of defining density, which is really important to understand, is that it's a comparison of the mass to the volume, or mass and volume of an object. And the way we calculate density is the mass of the object divided by it. Now you're going to see lots of density units over the next couple of weeks. So just to get yourself familiar with them, and units are very important. If you don't have a unit on anything, it doesn't mean anything. So density, again, is mass divided by volume. So if I have the density of, say, water, I'm going to take how many grams does a sample of water weigh and divide it by the volume, maybe mLs. So that's the density of a liquid. mLs is a liquid volume measurement. On the other hand, if I have, say, a cube or a cube of ice cube, I can take, again, its grams and divide it by its length times width times height, which would be centimeters cubed. You'll see these commonly, but then we're also going to see the large units of density. So grams times 1,000 is kilograms, mLs times 1,000 is liters. So that's the density of a liquid, again, when you have lots of the volume. And the density of a large solid, if you have a large sample, which is kilograms per meter cubed, which is the larger size of the centimeters. I googled this picture here to see just what is the most dense object. Turns out it's osmium in the periodic table, and it has a 22.59 grams per centimeter cubed. Just for reference, the density of water is 1. So that's 22 times more dense than water. So here's a couple of another chart that shows density of some common things, just for comparison. You know, air, which you would probably not be surprised, has a very small density. It's not very dense at all, and this is in grams per centimeter cubed. Water, as I just said, is 1. Ice floats on water, so its density is lower than water, 0.93. That's why it floats. A piece of wood also floats in water. We use water as kind of the comparison point for a lot of density things. And look at the density of wood. If you calculate it, it's less than water, so it floats. Aluminum, if you squish a piece of aluminum foil really, really tightly to get rid of all the air, it'll sink in water because it's more dense than water. Lead is heavy. Gold, of course, and better word is dense. Gold is very dense. These are a couple of alcohols that also would float on water. And they use this knowledge and some other things to kind of build this density column here, which kind of shows how they took some liquids, which the most dense liquid would be at the bottom here, honey, and then they put less and less dense liquids on top, and they would float on top if you put them in there very carefully, because they have different densities and the liquids won't mix. And then along the way, they dropped in a solid material, popcorn kernel, that also has the density similar to that area, so you can kind of see that in there. On Schoology, there's also another review video I want you to watch after this presentation's over, which shows you some of the calculations of density. So in just a minute, you're going to watch. A couple more perspectives here. If you take a slice out of the Earth's crust, so we live up on the crust here all the way to the inner core, and you look at the density numbers, the deeper you go, the more dense the material is. This is mostly iron or nickel here, and that's because as the Earth was cooling, the more dense things migrated towards the middle, and the lower dense elements kind of got pushed up towards the top. And less dense than rocks is right here, which is water. It has a density of 1. And then density also relates to our states of matter, and that's when I said density of a substance doesn't change unless you change the temperature. If you give the material more energy, the density is going to change, because a solid will expand and then turn into a liquid. Liquid has a higher volume than the solid. If you keep heating up a liquid and it turns into a gas, the gas has a larger volume. So density can change with changes in temperature. Make a note of that. Density can change with changes in temperature.